Hi, everybody. Well, thank you for coming. It's after lunch. I hope you had one coffee already. So before we get started talking about servers, I wanted to ask you, how many of you today are system administrators here today? Not many. 1, 2, 3. Good. 4, 5. Awesome. How many are DevOps? How many developers? Okay. Okay. So I'm a developer too. So sorry about that if you don't like developers. No, just kidding. I'm actually a musician. Wait, let me enable that. Yes, so I'm actually a musician, and I play the saxophone, and I started coding around 15 years ago, like very stupid games like like Pac-Man and Battleship, and it was a lot of fun. That's how I felt. Without the internet, you would just code something simple, and it was a lot of fun. That's how I got into programming. And then, I went into bachelor and master graduation, and after another 15 years of startups and web development, I work at this company. We do cloud training. So despite this picture and despite the rest of the presentation, this is a very serious company. So what's the agenda for today? Well, I already went through the About Me section, and so I was challenged by a friend that thinks that my slides are always very serious. So today, most of my presentation will be pictures and memes. So he challenged me. He told me, Alex, just try to do that. So this is my attempt. So there will not be a lot of text, so you have to listen to me. Then I'll try to go through a very simple and quick live demo, just to show you how you can put into practice what we have talked about, okay? So let's get started. So I want to introduce this talk by talking about this dystopian future, very remote, where data centers are everywhere, all over the world, and most of the internet is served and managed by these huge racks of machines, like this one here. Well, in this future, there was so much automation. They reached such an extreme level of automation that all this automation made sure that humans are not involved in the in the management of these machines and data centers. And guess what happened? Servers took over humanity, and machines are controlling everything we do. And they manage themselves. They are self-healing. They control our lives via super advanced software and magic. Well, there are still people that deal with hardware. There are still these all nice, beautiful, and happy people that remember the old days, and some of them are still enslaved by the machines. Just to let humans think that they still have a little bit of control over the situation. They really don't. Some heroes sometimes try to bypass the system and find a hole and destroy everything. But it's getting harder and harder because machines are autonomous and there's no way to get in, and unless you are that guy. So what is there that you cannot do anymore, or that people don't do really anymore in this future? Well, you don't really SSH into a machine much anymore, like to deploy to production or to do weird operating system patching or stuff like that. You don't really try to find people and find holes and vulnerabilities and just trying to kill them at the operating system level. That's something you can try to do. Hopefully it doesn't happen. There are some things like hardware provisioning and capacity planning that simply disappear in this future from the everyday life of developers, managers, and the whole organizations, and might be a good thing unless you really like doing it. But wait, isn't this future already happened sometimes in the past? So we are in the cloud room today here. So I would like to argue that this future sort of started already around 10 years ago when all these clouds started to spread around the world. They appeared, there are many of them. Plenty of people were and still are really doubtful and skeptic about this cloud. What is a cloud anyway? It's just a new word. It's still a computer somewhere. But then, this was 10 years ago, more or less. And then, a couple of years ago, this guy, how many of you know this guy? Werner Vogels? from Amazon, CTO of Amazon. So he introduced a new concept called serverless, or at least function as a service. Now we call it like that. So he said that no server is easier to manage than no server. So the idea is that if you don't have to manage a server, you're faster, you can deliver software quicker, you have less vulnerabilities, you have a lot less problems. So that was 2015 when AWS introduced a new service called AWS Lambda. How many of you are familiar with Lambda? A couple? 1, 2, 3. Oh, great. So Lambda was the first function as a service offering. And that's when this serverless revolution started. Well, it's a strange word. It sounds like marketing bullshit. Maybe it is. But we're here to understand what it is for real today. So the point is that the granularity of what you develop, deliver, and deploy is drastically changed with respect to the past. So you don't ship entire systems or apps or even services. You ship functions. So a function in most programming languages is the most granular thing you could do, and it's supposed to do one thing really well, really fast. It can interact with third-party systems. It can do a lot of stuff, but it should be one and granular and independent from most of the rest of the system. So in other words, FaaS, or functional service, is just a new additional abstraction layer on top of what we had. For example, containers. So probably there are containers under the hood, and containers were an abstraction layer on top of the operating system. And operating systems were an abstraction layer on top of physical hardware. And we have been doing this for a while. So what functional service is just the next level, the next layer of abstraction. Some people think it's a revolution. Some people think it's not. If you've been doing hardware and microservices and containers for the last 10 years, it's probably not as drastic as a change in your mind. But believe me, for a developer that is getting started today, this is a much, much simpler way to develop anything you are developing. So a lot of people are saying, like, why do you even need another abstraction layer? Well, after all, you know, containers are not, you know, they are sort of the previous layer of abstraction. Stuff like Docker, I'm sure plenty of you have used Docker already. Well, it turns out that even containers are not the definitive solution, probably not even functional service. You know, they come with a few problems. No technology is perfect anyway, so just let's try to stay on top and innovate, right? Well, why? I would argue that complexity is one of the main problems. So every new abstraction layer that you add is trying to hide a little bit of that complexity. But it turns out that by running containers, you still have a lot of the complexity that you still had while managing physical hardware. And solving many of the typical problems that you want to solve with containers or with any other previous technology was pretty challenging. So stuff like AUTOSCALING or high availability, high durability. And the problem is that it still requires a lot of knowledge you know, of the underlying layers. So an abstraction layer is useful only if it really hides the complexity. I believe, a lot of people believe, containers really do not hide that complexity. That's quite subjective. And, you know, this brings to problems, ultimately, stuff like that. Have you seen that happening in your organization? But I'm pretty sure you have seen this. And this happens all the time. And I believe, as a developer, but also as a solutions architect or a software engineer, that this happens because of two main problems. So let's see why. First of all, even if you use, you know, the latest best practices, the latest, you know, DevOps, even if you embrace the latest DevOps culture and tools and all the machinery that you can use nowadays, it still happens because of teams, people, skills, you know, kind of exist in these silos. So that, you know, your devs depend on a DevOps team, and they need to talk to each other. They need to organize configuration. They don't really share the same skill set. And, you know, as long as there are these silos, your organization will just keep delivering and developing slower and slower and slower. And the second reason is that this is what developers look like to a lot of people. So we really like writing beautiful code, deploy it, and repeat, and go and do something new. That this is heaven. This would be amazing if it was possible. But can you blame them? This is what they've been training to do. This is what any person, reasonable person, would love to do in an ideal world. Just write new stuff, make sure it works, ship it, go on with something new. That would be great. The reality, on the other hand, is that operations are still a need. They will be always needed because you cannot stop provisioning hardware and computing power, storage, networking, and security configuration, and firewalls. You know, this stuff is important. So I'm not here to say just forget about operations, forget about you know, maintenance. It still exists. The point is that in the everyday life of a developer, it shouldn't be the like 90% of your time. You know, the good news is that with this new revolution, with the serverless revolution, you know, it comes with a lot of benefits, with a lot of features, with a lot of pros that we want to highlight today. So one of them is auto-scaling. So in the ideal world of function as a service, I develop a small function, I deploy it, I give it to my cloud provider of choice, and they will make sure it scales. Think of it as a container, but you don't see all the cluster management, provisioning, and stuff. Well, it comes with a lot of best practices that, you know, we as a tribe, as a new tribe, inherited from the previous ones, like infrastructure as code. So you want to define your application, your requirements, your links between your components as code, so you can trace when they change. You can deploy to multiple environments. You can make sure they, you know, you can monitor whenever they change or whenever something goes wrong. Another good thing is that by design, functional service supports a lot of languages, a lot of runtimes. So since every function that you deploy or design in your system is totally independent from the others, it means that each function can potentially be developed in a totally different language with a totally different stack. So it's not that it's impossible with other technologies or even with containers, but this is by design. This is the way you develop individual functions, one language. And what this enables is that you could have a distributed team with a very diverse skill set. They just need to agree on, you know, microservice interfaces and stuff like that. And every function could be like one in Java, one in Python, one in Node, one in Go, one in, you know, you can have a very diverse team building things together. And this is quite an interesting enabler, especially in the modern world of web or system development, whatever you're coding. This is my favorite. This means that you don't want to pay for idle. So whenever you rent a server or a container or whatever you are using today, you're paying for it like hourly, right? You pay, I don't know, 5 cents per hour or even less. And that's pretty cheap. That's amazing compared to 10 years before. But you're still paying for idle. If nobody's using that server, that container, whatever you are using, you're still paying for it. So we don't like that anymore. So the serverless tribe really likes to not pay for idle. Indeed, in the functional service world, you just pay for the milliseconds of actual execution of your code. So you invoke your function for 200 milliseconds, that's what you pay. You don't invoke that function for the next 20 days, zero cost. That's the point. And most of all, even from the network and hardware optimization point of view, if there should never be a 24/7 server, not even a process just waiting for events or requests to come. If nobody's using your function, it will be dismissed and recreated, spawned when needed by the cloud platform. So you never oversize, you never over-provision, you never under-provision. This is the ideal promise of elasticity that the cloud tried to tell us around 10 years ago. it was true at the instance level, now at the container level. I think the more the granularity get smaller, it means that it's just easier to manage, to maintain, to interact with, and even cheaper to pay for it. By the way, so a lot of serverless offerings come with a very generous free tier. So you can experiment, you can prototype, you can even build a whole new product, a whole new startup, a whole new something without spending a single euro or dollar. And still, once you have that, you already, it's not a prototype. It's not something that you have to throw away whenever your product gets real users and real traffic. What you have built, since it's auto-scaled by default and blah, 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 it's already production ready. It's a solution. You don't have to change everything once you get real traffic and real users. It's ready to scale up to millions of users already. I know what you're thinking. There must be a server somewhere. Yes. There are thousands and thousands of servers. There are thousands of containers. Whatever is below this abstraction layer, the good thing is you don't care anymore. So please don't come to me after the talk saying there must be a server somewhere. There are. The thing is, it's serverless because developers or whoever is coding, like data scientists, whoever is putting code into this platform, they don't see servers anymore. You don't SSH, you don't maintain, patch, whatever you used to do with servers. They disappear from your work cycle. Of course, there are stuff like security and best practices, development best practices that you need to keep into consideration. So just because the cloud provider is managing a considerable part of the system, like all the container and provisioning and auto-scaling, it doesn't mean that you're free and then you don't have to manage security and avoid stuff like code injection or, that's still on you. Application level security and best practices are still on you. So if you're a bad developer, you'll still be a bad developer. I can't do much about that. Because the point is that you should accept that in the cloud, there is a sort of shared responsibility model. So that the more you delegate to the platform, the more the provider is doing for you, but all the rest is still on you. So just don't delegate too much, okay? So what happens once you embrace these concepts? This is the reaction that a lot of developers have. Like, you can think, well, so I can build an entirely serverless system and never manage a server again in my life. And that's pretty much what happened to me. That's why I'm here today to tell you how amazing this stuff is. So you can. There are a few problems you need to take into consideration. For example, just to mention one, databases are problematic, not all of them. So there exist two main approaches, like a group of people are like, just go NoSQL, you have low latency stuff, you have a lot of concurrent connections, you don't have to deal with joins and with a lot of blocking heavy stuff. It's much easier to make NoSQL scale. And that's the big problem you have with relational, like with SQL stuff. Especially in serverless, since your compute layer is free to scale up to infinity, you have a lot of connection pooling problem because you cannot have infinite connections. You have permissions. How do you manage granular permissions on a function by function level, not on an application level? And then how do you manage auto-scaling of these relational databases? It's kind of problematic. So relational has been kind of tricky so far in the serverless world. Good news is that luckily all the main cloud platforms now offer some sort of relational, super globally available, single-digit latency, beautiful pay-as-you-go databases. So here I'm mentioning, Google Cloud Spanner and Azure Cosmos DB. Just check them out; they're beautiful. My favorite here is Aurora for Italians. It's the new, it's kind of the, so it's MySQL and PostgreSQL compatible if you like open source databases. It's offered by AWS. The good thing, and I'm mentioning it today, is because just like 10 days ago, a week ago, AWS announced that now there is a serverless version of it, meaning that similarly to the functions that I was talking about, even for a database layer, you are charged on a per second base, not per hour, not per month, not per year. So if nobody's querying your database, if there is no request, it costs you 0. So one of the best definitions that I know related to serverless is that a system is serverless if it costs you 0 when nobody is using it. And this is a property that not a lot of systems have. Think about it. How many of your systems you have designed in your life costed you 0 on day one when nobody was using them? You always have some sort of license or hourly or monthly or daily cost. This is what I really love of serverless. So this is great for prototypes, for startups that want to scale. But if you apply the numbers to even a big system with a lot of users, it's still convenient. Because unless you have a very steady, constant traffic, and no application has that. If you have spikes, if you have infrequent traffic, think of like cron jobs or stuff that doesn't run every single minute or second. You know, this pricing option is pretty interesting. So, doesn't mean that you should just go home and delete your EC2 instances or your servers, just shut them off. Well, no. The point is that not every scenario is a great fit for serverless. I would argue that most scenarios are. So there are still scenarios where you don't want to use a serverless technology and that a server, a 24/7, whatever, container or server is still a better use case. There are scenarios where it makes sense. What I'm here to tell you is that most of the scenarios that you are probably working with are a good fit. So I invite you to check it out. I do have examples, so let's talk about examples. I have to apologize in advance for the incredible amount of acronyms that I'm gonna mention. I'm talking about AWS because I'm more comfortable and because AWS is just innovating, just leading this market. So I'm gonna mention a few acronyms and services. If you're not familiar or if I forget to explain one or two, just stop me. I'll try to catch up. So, 4 use cases here. Top left, this is quite a common one, probably the most common in the serverless world, where you want your compute layer function service, in AWS it's AWS Lambda, to manage API requests, like think of a RESTful API. So you want to have an API gateway in front of it. That's how AWS calls that API HTTP layer, which will act as a HTTP trigger, invoke your Lambda function, and then you probably have some sort of database. You know, this is the standard 3-tier architecture. You probably have a client somewhere, but the client could be just a static page, or that's the new way of doing websites, right? So here you can put any database. I've chose DynamoDB because that's up until now the most used choice. So we have a second use case. Oh, sorry, I forgot to mention, in this scenario, every layer of my architecture will scale independently from the others. I don't have a server running. There are servers running, but I don't care about the servers running. So API Gateway will scale. Lambda will scale to hundreds of machines eventually, or containers. DynamoDB, that's what it does. It will scale to single-digit queries on a key basis. And the same holds for all the others. So the second scenario the second use case I want to talk about is what I called event-driven file processing. So how many times happened to you that you had users like uploading a picture or a file, and you needed some sort of logic to process that file, and that is like in the API world, in the RESTful API world, that's usually a synchronous call that sucks, and it doesn't really scale well, mostly because of storage. So what you can do with function as a service, and that's why it was a game changer in the first place, is that you can have anybody upload a file into the storage layer. The object storage in Amazon is Amazon S3, and that layer will trigger an event and invoke your Lambda functions whenever a new object is created or whenever an object is updated. So on file creation or file update, you can invoke a Lambda function, process the file, eventually save the processed version, or push a log somewhere, update a dashboard, do whatever you want. So in most of these scenarios, Lambda or function as a service acts as a compute glue between all the services that you are using. That's another interesting concept of serverless. And then here I have another scenario, another use case, where you have some sort of messaging service. In this case, I've chosen Amazon SNS. It's the simple notification service that helps you manage, push notifications or emails or anything that is a message on a topic per topic, similar to like a PubSub messaging system. So similarly to what you did for files or objects into S3, you can do the same with SNS. So as soon as there is a new message into an SNS topic, you can get your Lambda function invoked and process that message, or republish it somewhere and build a fully event-driven system this way. Or if instead of SNS you use Kinesis, Amazon Kinesis is a very similar service where instead of topics and messages, you talk about streams and batch. So you can batch process records with Lambda. So identical infrastructure, Lambda will pull records from the stream and process them in real time, similar to what you would do with Kafka or other services. So last but not least, fourth use case, so in Amazon you have this global content delivery network called CloudFront. So you can use it to deliver like static files, like JavaScript, HTML, CSS. That's quite useful, or images, quite useful for websites. But now what you can do is you can use, instead of Lambda, you have a variation of it called Lambda at Edge, which allows you to deploy your Lambda functions not into the data center, but into the CDN edge points. So Amazon has around 14, 15 regions, like big data centers and stuff. But it also has more than 100, maybe 102 or 3 point of presence as a global content delivery network. So you can now deploy your Lambda functions to the edge and compute stuff directly as close as possible to the final users. This enables a lot of other scenarios, like you can do cookie manipulation, headers manipulation, do A/B testing, or do rerouting of requests. So this is quite another interesting. So of course, this is just 4. There are many more. So this is a screenshot I took from a webinar that I recorded a few months ago with my friends at Serverless Inc., serverless.com. Check it out. So just to pick a few interesting use cases from here. So you can see webhook, that's interesting. So you can just create an API and use it to process webhooks, like from Stripe or from any API or service that allows you to bind a webhook. Or cron jobs. Cron jobs is perfect for a functional service. You don't want a server running 24/7 just to run a 1-minute cron job at 4 p.m. every day. So you can just use Lambda and like CloudWatch in AWS to trigger an event once a day at 4 p.m. and process that, whatever you need to do. Another interesting one, like web scraping or image processing. I mentioned that with S3. You can have Alexa skills. They are heavily based on Lambda because you just need this highly scalable, stateless compute layer, and Lambda is perfect for that. You can do IoT stuff like data collection, data processing, data manipulation, aggregation. You can build chatbots, and you can do basically any time you need an ephemeral compute layer that you don't care about the state or the server, and this is a good use case. If you're curious, you can check out a few free webinars, or if you want to learn more, that's what we do at Cloud Academy. We teach this stuff. I'm not an instructor, but if you're curious, check it out. There's a lot of free content. So what are the most used or the most known function as a service alternatives. So here I reported the 3 main ones. These are Amazon, Azure, Microsoft, and Google Cloud. I would say that Lambda is the most advanced and feature full. A couple of these are pretty much new, like function project is from Oracle. This probably died last week already. This is from OVH, so Waka, OVH, or IBM. They are even sponsoring this conference. And they do have a function as a service offering. A couple more, webtask.io and hook.io. They all allow you to just bring in code as a function and execute it whenever you want. Sorry. So today I'm going to demonstrate you a little bit of Lambda, just because it's probably what you want to get started with. It's just easier to use and pretty much leading the market. So there must be a better way to choose a cloud provider, right? If you cannot choose a cloud provider because of your organization or because you just want to use something open source, so you're free to modify it, to contribute to it, there are open source function as a service alternatives. So here I want to mention OpenWhisk and OpenFaaS and Iron functions. So just to give you an idea, so OpenWhisk was initially developed by IBM, and it's growing. It's now integrated into Bluemix, their cloud offering. But I will say that Iron functions is pretty much dead, and that OpenFaaS is just taking off. It's an amazing project. So check it out on GitHub. You can contribute. You can build your function as a service layer on top of your Kubernetes cluster or on top of your Docker Swarm cluster, whatever you are using to manage containers. So you can offer to your development team the same abstraction to develop and deploy functions instead of containers or apps or whatever they are developing. What about tooling? So there are a lot of tools. What I'm using most of the time is the Serverless Framework. I'll show you why. So most of these are either focused on a specific language like Go Sparta. If you use Go, check it out. If you use Python, check out Zappa. If you use like JavaScript and mostly for web development, you can check out Dozen. This is actually from a friend from Milan. Claudia.js. This is for Amazon. Amazon SAM, the Squirrel Serverless Application Model. I'm mostly using the framework because of that. That's popularity, but also maturity, and also, it's cool. Just check it out. So if you want to get started, you can use the Serverless Framework, and it covers most of the scenarios I was talking about. All the others either focus on a specific language or on specific scenarios. So the Serverless Framework is the one that covers most of them. So I will go on and try a live demo, but we have 2 minutes, so more or less 2 minutes. So I can show you a little bit what the experience would look like real quick. Can you still hear me? Okay. So here I previously created. So here is the AWS console. So you can use this service called not code build. I wanted to use code star. It doesn't? Code. Oh, it's a mirror. Sorry, guys. Here and here. Better. And then here, scaled. Done. Sorry. 10 seconds. Nothing? Yes. So sorry, here is the console, the AWS console. So you can use a service called CodeStar. So this is the code suite of AWS. And I already created a project. I call it LinuxLab live demo. It'll be a very quick one. But still, it allows me to create a project already auto-scaled and with a continuous deployment CI/CD pipeline already in place. It got bootstrapped with an API already defined. So this is my application endpoint. It just probably renders hello world. The good thing is that you also have an IDE directly in the browser. This is called Cloud9. Pretty recent announcement. If you already knew maybe Cloud9 a couple of years ago, it got acquired by AWS. And now you can use this to build and develop your functions. So this is my function, this is Python. All it's doing, it's outputting hello world and like a timestamp. So it also gives me here in the bottom a way to git push and to install requirements and to manage my infrastructure. So I can do just hello LinuxLab attendees. And once I've done that, I can just very quickly git is it working? Maybe. Well, yeah, it's actually working. I can do git commit -m. Okay. Can you see anything? Sorry, the resolution is weird. Okay, instead of showing you, I'll tell you what would happen. So here I can do, if I git push in here and I change something, CodeStar will automatically trigger the continuous deployment pipeline, which is here. So there is a code commit is the GitHub of AWS. You can also use GitHub. You have code build, which will make sure that your project is built if you're using Java or other compiled languages. You can add a testing stage, and then you have the deploy stage. So this is fully infrastructure as code based, because the specification I'm using is using CloudFormation, which is what you use inside AWS to do infrastructure as code. And the good thing about CodeStar is that all these building blocks are put together to provide you a much better experience. So I wanted to show you what's the best way to get started. If you can write a simple function as simple as this like 12 lines of Python, could be even simpler, you can get started and that function will be production ready. So I hope you will give it a try and go serverless. Thank you very much.
Thank you. Okay, so we have also a bit of time for question and answer. So do you have any question?
No questions. It was super clear or not interesting. One question.
So at what point would you believe that the cost that you pay for serverless?
Sorry, I didn't hear you. Can you speak louder?
Yeah, so pardon my bad throat.
Sorry. Me too. I got a flu today.
Yeah, okay. Am I audible now?
Better.
Yeah. So let's say you pay something for the serverless compute, right? And it's usually higher than what you would pay. Assume it was 100% occupancy.
So the pricing.
Wait, my question is not.
So you're
yet done.
saying it might be more expensive than what you can build with that.
No, I have more to say. Yeah, I'm still asking my question.
You're asking. Okay,
Yeah.
so some use cases are not cheaper.
I'm still asking my question. Yeah, so at
Sorry.
some point, let's say you have 100% occupancy, you will be paying slightly more or way more than what you would pay otherwise. Now, in your experience, what is that tripping point where you believe that serverless would become more expensive than me having to compute by myself using my own infrastructure?
So there is no like objective number that I can tell you like above 10,000 requests per hour, it will be more expensive. If you do the math, you can find out numerically where it gets more expensive on a like per request or per computation. What I can tell you is that if you just consider the computational cost, it doesn't make sense. You should put in also the maintenance cost, the people development cost, and the infrastructure management cost. So what you can finally put away from your capacity planning and budgeting is all the infrastructure. There's no operating system patching. You don't go back and patch your OpenSSL into your servers. All that cost that you probably wouldn't put into the compute cost now fades away from you. You don't have to do that anymore. So what I can suggest you is just don't go to the numbers of how much does an hour of computation cost you with Lambda or with EC2 or with Google Cloud Compute Engine. Consider everything. So the total cost of ownership of your microservice or your system, that's what you should look for. The fact that you have zero administration, auto-scaling, and production-ready prototypes, that's invaluable for me.
Okay, there's no more time for questions. So thank you, Alex.
Thank you, everybody.